So, giving you a brief overview of what Ambient's journey has been. Ambient team scientific was created with a vision. Okay, vision to develop AI compute technology, ground up, to deliver high performance, low power, at an affordable and with flexibility in programming. These are the four key ingredients with which we started the journey of creating ground-up innovations for AI processor. With these technologies, we wanted to power AI applications which becomes portable, affordable, and as well as flexible for on-device IoT and edge applications. And this can power everyone in their everyday lives so that AI becomes very portable and affordable for everyone. Okay? Yeah. So let me quickly walk you to the slides. So that's the vision and the challenge that pretty much everyone has in the AI space is the affordability and the flexibility of programming, as I said. Today's AI is not portable as well as flexible in programming. So what we have done is we have created a highest performance, very low power, and versatile and a programmable AI processor. And this comes from an innovative technology called DGAN. And the DGAN is a mix of high-speed digital circuits as well as analog computing techniques for matrix computing. And this becomes the core of the innovation. The Ambient team spent 5 years in R&D to achieve this DGAN core technology. And based on DGAN core, we created our own MX8 core, which powers our first product, which we are today very happy to announce and report that it's going into high volume production. Okay? And this is done at TSMC in 40 nanometer process node. Along with the core, the team has achieved developing the AI compiler as well as the SDK and some core innovations in the instruction set architecture to do matrix computing in a very efficient manner, which becomes the core of AI compute technology. We have also innovated at the SoC level for the GPX10 product with microwatt ADC as well as some core low power technologies to make the total system power at a very low level in terms of microwatts that we do AI inferencing. So what does this enable? It enables several applications in the market, and you can see its voice and sound, sensor fusion wearables, as well as predictive maintenance for industrial IoT applications. So some of these products that we are working very closely with customers are going into production in this quarter one of 2024, and that's what we are announcing today here. Some of the technological innovations that we have built, as I said, we have custom instruction set architecture. Our DGAN matrix computer, which becomes the core of the technology that is innovated, which combines high-speed digital circuits as well as analog techniques to compute AI. And what does it deliver? It delivers, as I told you, very high performance at a very low power consumption, both affordability as well as portability. And the flexibility comes through, in the world of semiconductor chips, flexibility is commonly known as programmability. And programmability is very difficult task to achieve. Flexibility as well as programmability. And that's what this architecture has enabled. And we have our own memory technology, so 3D SRAM, for computing the AI, and as well as low power clock. And as I told you, at the sensor, at the SoC level, we have done innovation of microwatt sensor ADC Now, what does microwatt sensor ADC achieve? It achieves a sensor fusion AI that you could do. That means you could connect simultaneously 20 plus sensors to our chip and do sensor fusion AI, which is again a very big innovation in the space of on-device as well as IoT AI to enable wearable applications in the market. So with DGAN core as well as the MX8 core, which went into our first product, GPX10, we enable a roadmap here. And the roadmap consists of 32 cores as well as 64 cores that's coming up as we see. As you can see, this will enable several edge AI applications, including industrial, automotive, vision, and sensor fusion AI. So GPX10 is getting into high volume production, as I said, in Q1 2024, and we'll be soon kickstarting the 32 and 64 cores in our roadmap. And this particular technology, DGAN, what it provides is that it is very scalable in the process node, number one. Number two, when I mentioned that it's a mix of high-speed digital circuits and the analog computing techniques, we also achieve manufacturing yield, which is a very tremendous task to achieve with this kind of technology that we have innovated ground up to achieve a manufacturing yield. And that we are doing it today in TSMC, 40 nanometer, and the yield is pretty much at 98%, if I may say, after all the tests. Thank you, and we are open for questions.
I'll show you some of the devices that are possible with this first product that we have built. These are devices that are being built by customers right now. Should be available in 2024. First device is a very small camera. Now there are a lot of cameras available in the world. But something that can detect an object, including a gun, in a school. And the selling price for this will be $20 or less, the overall thing. So that means you can protect an entire school for $1,000. This can detect objects, it can detect people, it can detect dangerous items. So this is being worked on by one customer right now. And this will totally power with the battery. That means you do not have to run wire across the school, and if the bad guy comes, he can just cut the wire and go away. None of that problems will exist in this. So we are really making it affordable and very intelligent. That's the point. There's another device we are building with, again, a customer. Can you guys hold this? This is a locket that will have a small battery in the side, and the chip is on the back. This will be able to detect fall. It will be also able to detect if a kid is being assaulted or attacked, or there's a case of domestic violence. It is also being currently, there's a company that is trying to use this for ECG, and the selling price for this, that is retail selling price for this, we intend to make it less than $15. Okay, and over time it should go down. So that means I can have this give to my mother, and whenever she has an asthma attack, I will get a text message, I can get to a doctor, or she can get to her doctor, or doctor can be notified by themselves. So this much intelligence that we are bringing to the edge. There is yet another device. In future, all this changing the slides, virtual assistant will become this big, will become part of my my pin. So it will look nice and also not cause all the problems that it's causing. This is also being worked right now. The camera that I showed you will be able to show you some demo also at the booth if you come, some of these live demos. It is being used by a customer to monitor the drivers so that they're not watching movies while driving. So, or if they fall asleep, or they for some reason have some medical condition and they fall on the wheels, we'll be able to detect. This is, I don't have a prototype here because customer took it all to do the selling, his selling. We'll have one in the demo center that they will send in our booth. So these are some of the devices that have never been possible in past, and the reason is that AI requires a lot of computing, and a lot of computing is expensive, consumes a lot of power, and a lot of time when people cut corners, this is not programmable. Means it can be done only for one application. That means there is slight change in application. You cannot build that application with non-programmable chip. Like for example, I could detect asthma with this if I had it non-programmable, but could not detect a fall, or could not detect somebody getting assaulted, or could not detect ECG conditions or the heart condition. Achieving all these four features is very difficult to do. There are actually many companies that have been trying for past 5-6 years. Some have given up, some are still trying. We are the lucky ones to have done it first, and gladly we have achieved all of this. So what we aiming to do is make AI affordable, not for the Google and Amazon only, but for a common person in everyday's life. And we are here. It took us 5 years of R&D. And as you know, 5 years, most people consider startups dead, except if you're a medical company, right? But we are alive, we are going in high volume production, we put our head down, and in 5 years you'll also see we made no noise whatsoever. Put our head down and work. If we could not crack the code, we would have packed our bags and gone home. Would not have bothered you guys or given false hope. But now, we are there.
Question.
Where are most of your engineers? What countries?
Right now in USA and India.
What's the split roughly between the two?
Around 30, 70.
And then, did you say 14 nanometer or 40 nanometer?
40.
40 nanometer.
40 nanometer.
This can do so even in 40 nanometer. And just to give an idea, our performance which we have measured is better than the 7 nanometer big companies, big internet company chips that have been done with a few $1 billion.
Yes.
So did you say 40?
40.
40, yes. However, the technology itself can scale to any technology, has no issue. To any node, it has no issue.
Yes.
You mentioned about high volume production. Where is the location would be or
At least 3 continents.
3 continents?
Yes.
Where?
No, production will be happening in
TSMC.
Asia, some part being done in USA right now, and some part being done in China.
Okay, thank you.
So Asia includes Taiwan, Thailand, India,
Malaysia.
and Singapore. Chip operation, as you guys know, is very complex, and it takes a lot of effort, especially if you want to make it affordable.
Hello, I am Claire, a semiconductor analyst coming from South Korea. And I'd like to ask about your relationship with TSMC, the foundry partner, because there are hundreds of AI processor that these companies in the world, right? And your company is one of the hundreds of thousands of AI processors that these companies. So everyone wants to work with TSMC because TSMC is the only one foundry. So how could you make a
Collaboration.
close relationship
With TSMC.
as a startup? to work
First of all,
on-
I understand the question. So 2 things. Hundreds of processor company, when you say that processor word is English word. When you translate the same word in electrical engineering, processor means a chip that can be used in many applications. So when you look at chips that can be used in many applications, those will be chips like NVIDIA, Intel, Cerebras, AMD. Chip that can be used in many applications but can consume less than 1 watt power, we are the only one. So that's why we have no problem there. Other thing is, this technology is such that it can be ported to any foundry node. We have no issue with that, just with 3 months effort. So we are very glad that TSMC has supported, and TSMC is an amazing company. Even though we were there for 5 years, they did not give up on us. So we are very grateful, and we will be grateful.
Very good. Go ahead. Yours.
I'm pretty uneducated on how all this works, but I do know that a lot of AI right now is cloud-based.
Yes.
Is what?
Cloud-based.
Cloud-based, and I've been wondering when all of the AI will be on my smartphone.
Yes, and that's what we are enabling.
That's what you're aiming
That's
at.
what we are. We do in all these solutions. You don't have to connect to the cloud, right?
Yeah.
So none of these applications you need to connect to cloud. We run everything on the edge, on the device. We do AI inferencing on the device. So what you get with this is that you get advantages of data privacy, security, and round trip latency. A lot of applications that are real-time applications need real-time response, right? I mentioned industrial IoT. I mentioned some of the automotive in-cabin situations. These need real-time response, right? You cannot wait for long, right, before you.
Yeah, your device cannot say, oh, sorry, I don't have wireless connection.
Wireless connection, right?
I mean, you hit the nail on the head with this camera that can detect
Yes.
the gun in the scene.
There you go.
Security applications.
Correct.
Right.
Really interesting.
Exactly.
At least you can sound the alarm even if internet has been disabled for some reason.
In fact,
Yeah.
as GP mentioned, we are talking to some of the folks for gun sensing.
Yeah. Guns and school security. That's
School
actually
security.
two big things on our right here in US.
Go ahead.
I'm curious about what kind of key technology is used to manufacture this kind of ultra low power system.
What kind of key technologies are used to manufacture?
About, for example, about transistor. What kind of transistor you use, or what kind of circuit design you use.
Manufacturing
this
transistor.
is a common trap, and a lot of startups get trapped in this common trap. We are using a standard TSMC technology, no special component required. So it's like you just go to a restaurant, order the food is ready, you get the food. Same way, we order the wafer, they give us the wafer, and we are off to our mark. We do not require them to even know what is inside.
Then you need to use FinFET or how it methodology.
We can use anything that the foundry is offering. Right now we are in the 40 nanometer, there is no FinFET. The next chip we are going to build, that will use FinFET.
What about how it?
Power gate?
Power gating.
Power gating, we have this type of low power chips have to be very sophisticated power gating. We have actually invented two technologies for which we had to fight with the mighty Intel and Samsung to get them approved.
Do you use how it?
You have to. I mean,
You have
for
to.
such low power,
ultra
all
low.
kind of, there are at least 20 different tricks you have to use. Power gating is not sufficient. Actually, it is the easiest to achieve.
Yeah, I think this one is.
Who's moving your financial backers to date, and how much money have you raised to date?
That part we are not disclosing today, sorry. But we are at least 1/10 of any other competitor that has reached this stage. 1/10 the expenditure. And that's because I work around 72 hours a day.
Go ahead.
My question is about your competition, right? Let's think about maybe microcontroller companies as an example. They have vast ecosystems and they have very large channel partners, distributors, things like that. How are you going to market right now? And what's your plan of going to market over the next 12 months? Is it going to change?
Similar mechanism, we have actually, for some of the largest distributors in USA have already signed up with us. Because see, there is really nothing available. Customers are demanding for this. And the microcontroller based solutions do not serve the purpose because they cannot consume such a small battery. I mean, now in our case, some applications we are consuming microwatts. They are at least 1,000 times more power consumption. So that cannot be battery. So the competition cannot be battery operated. We are the only ones who can run AI algorithms with battery operated.
And what type of tools are you providing to your potential customers to make it easy for them to design your chips to get them to market quickly?
Yeah, we have a full SDK that is being released. Actually, if you come to our booth, you can see the whole thing in action. It's being released to customers. Our customers are now able to build their application within 2 hours. Definitely within 2 days, our claim, but one also built it within 2 hours and was up and running. And they are doing this ECG detection, the heart detection.
And we have also got the AI compiler which basically has support for all kind of neural networks, right? If you take the CNN, RNN, LSTM, right, FCN or deep neural networks, it has support for all those. So that's where, as GP said, right, it took 5 years of R&D. The 5 years of R&D is not just to build the DGAN core, but it's also to build the AI compiler, the complete instruction set, architecture to bring up. It's like a core
Massive
processor,
work.
massive work. You guys know, right?
Just
So-
to let you know, the need is so much that we have more than one customer waiting for over 2.5 years for this product.
And then last question for me, I guess, is just on the, you talked about some of the products that you designed into very low cost products, $15 cameras and things like that. Would it be safe to say that your chip is somewhere in the low single digit dollar amount?
Yeah.
Just like $1 to $2?
Yes.
GPX10 is yes, in the single digits. You're right.
One to two or 5? I'm just trying to get a sense.
It's
Yeah.
you seem like an expert in this area. So
Yes.
obviously it's volume based. Some of the guys who are getting, for example, the ones who are ordering very large volume, it is less than $5. We can disclose that much.
Less than $5.
Yeah.
Yeah.
We will have this type of device in consumer's hand in less than $15.
Including the software.
Okay, go ahead.
Hello again, and thank you for the opportunity to ask another question. I understand that some chip companies are focusing on advanced packaging, technology improvements to achieve low power consumption. So how much does your company rely on packaging for low power implementation? Do you depend entirely on TSMC for mass production, packaging, and testing, or do you work with TSMC's another packaging partners like ASE Technology or N4?
So we are picking, we have picked 3 partners just to be sure. Taiwan, Thailand, China, all the popular places. Our technology does not depend on packaging for delivering low power. However, somebody is doing hyper marketing, I'm sorry to. Packaging doesn't, maybe 2-3% role in the entire equation.
It doesn't, yeah.
So in summary then, to implement that ultra low power, it's mostly dependent on your
Core.
design, your core,
Core and-
design, and
yes.
making transistors are business, right?
Architecture, circuit, and the software optimization. Most of it is circuit. One thing I do want to make here is that we are probably the only startup that has a very sizable, very advanced circuit design team. The companies that do circuit design very successfully are Apple, Qualcomm, not entirely, maybe just 20% of their work. Intel used to have a very good circuit team that is kind of waned out now, but last. So we are probably the only company that has a sizable circuit design team. Most startups do not dare because it's expensive.
Well, Mike, yeah.
Hi, there was a slide on the custom instruction set architecture. Could you talk about, why you need to build the custom instruction set, one on top of the ARM instruction set?
So 2 reasons. If you have ever built a microprocessor, if you talk to people who have built microprocessor, I have built it from when I came out of college, I have only built microprocessors. Okay, a few maybe 3-4 years, I was building ASIC and other chips. And so if you build microprocessor, actually, either you use the instruction set as it is, or even if you change a small percentage, the amount of software required is actually very high. Almost 90% of work will need to be redone. If you scan the peripheral, the mathematics, there are multi-level mathematics. It's called scalar mathematics, vector mathematics, a little bit floating point based vector mathematics, and little bit more complex vector mathematics like GPU. The matrix computer requires vectors of vectors, just if you go in the mathematics. So there was no instruction set available in the industry that could do vectors of vectors. The only one available was a TPU from Google, or a little bit tensor work that that NVIDIA is doing. Obviously, those are not available to us. And the other part is they are limited to only 3 by 3 matrix compute. They can only compute very small equations. We compute 100 times bigger matrices, and we do that in one cycle. So it's actually able to eliminate a lot of bookkeeping work, which in case of CPU will consume around 95 to 96% power.
So CUDA is not, I mean, I understand that, obviously not.
CUDA is a software layer, right? CUDA is not the underlying.
It's not the underlying.
Hardware is the tensor or GPU, right? The two.
Yeah, the most important thing there is that we do several neurons we compute in single cycle. Gentlemen there mentioned regarding the MCUs, right? Most of the MCUs are powered by ARM, right? And ARM, if you compare with ARM will do pretty much a 32 by.
ARM is so let's compare with ARM. ARM is a single thread machine. In our case, the 10 core processor is 3000 thread machine, just to understand. So from performance point of view, unless we go down to the changing the instruction and building the circuit blocks that can support those instructions, till then it's not possible to beat it's not possible to achieve this performance and power consumption.
Go ahead.
Thank you for taking my question. So I want to go, you mentioned to the other gentleman that you're developing an SDK, or you've developed an SDK. Are you doing any sort of model development to help kind of catapult the use cases?
Yes.
And then my second question is kind of going the other direction. How are you ensuring that you become part of the design process? So for example, in the camera application, you're not building the camera itself. So how are you ensuring that you are part of that design for that particular use case? So two different dimensions in the success factor.
This is a very important question, and actually one that bites or hurts startups in later part of their life if they're not thought through properly. So in our case, one can develop AI algorithm using Python, and you fit into industry standard tool called Eclipse, which is basically so this fits. So for a developer, it will feel like they are developing just an ARM application. They're not developing anything special. And if they have already done AI algorithm, if they have built AI algorithms, they would be able to use Python to compile their AI code. To catapult as you said, we have many application examples that are fully done, that are working. So if you download our SDK, you will be able to run on your own on our hardware development kit.
And the models for that.
One more thing. Yeah, sorry. The models, we are providing the models right now, some of the models, but the idea is that the customer or the user will be able to develop their own IP. That's how their application is different than the competitor's application. If that is not done, then let's say the chip company provides the entire application. Then you are just a plastic product company, right? Just an industrial design and marketing company. But in our case, since we are providing a complete framework and allowing users or enabling users to develop their own models, that means they can build AI IP. And in our case, we have assembled some data for some of the applications that we show them as examples. But for other data, we are collaborating with the ecosystem partners who can collect the data and train the models for customers.
I believe we have time for two more questions.
Yes, go ahead.
It's not a serious question. I was just wondering if you could reflect on life as a small startup in comparison to some you mentioned, like what, NVIDIA, I think has got this thing on a GPU. And I don't know any of the language, but I'm just curious.
So most of the startups that actually can make it battery powered, they do it for one application. And when the application changes slightly, let's say that I am doing it for gun detection. Now I want to say, you know what, I want to detect a different model of the gun. And the chip cannot do it anymore. In our case, you change the software, you retrain the model, and you're good to go. And very soon we will provide that retraining on the edge itself.
So do you do the software as well, or your customers do the software? They take your chip and they do the learning process and all of the software development for that, I guess.
We do what is called middleware. The software, sir, is around 10 different layers. And the chip companies have to build at least 8 of those layers. So all chip companies have to do it. And then some companies will build the 9th and 10th layer also as an example and give it away to customers to make it easy for them. That's what NVIDIA does for a lot of security applications or the other applications.
Reference applications, right?
They call it
Reference
reference design.
How many people at your company?
We are more than 70 people now.
Thank you.
Yeah, thank you very much.
Any more
Okay.
questions?
Thank you very much for
Thank
your
you.
time.
Thank you once again, and
For
thank you
attending.
for coming in.
Thank you very much.
Thank you.